Let's start with a weird thought. What if time, the ticking seconds, the rising sun, the sense of past, present, and future isn't actually real? What if time is just something humans invented to make sense of, well, everything else? Because here's the thing, clocks exist, but does time? We take time for granted. It's the backbone of how we understand our lives. You're born, you grow up, you get older, you die. There's a sequence. But underneath all of this is an assumption that time flows like a river, that it moves forward and we're just riding along. But modern physics, especially relativity and quantum mechanics, tells us something very different. Time, it turns out, might not be a river at all. It might not even flow. In fact, some scientists argue that it doesn't exist in the way we think it does. Maybe not at all. We're going to spend the next hour exploring what that could mean. We'll talk Einstein, black holes, entropy, simulations, perception, and why the universe might just be a big block that never actually changes, despite how it feels. We'll question whether your past and future selves are just as real as the present one. And we'll ask, if time isn't real, then what is? But first, let's ground ourselves, or unground ourselves. Let's talk about how humans invented time in the first place. The human time hack, our ancestors didn't have wristwatches, but they did have the sun. Early humans noticed patterns, days, seasons, moons, and those cycles were useful. You could plant crops, plan hunts, predict floods. Fast forward to ancient Egypt. They invent sundials. The Babylonians divide the day into 24 hours, a number that weirdly stuck. The Romans add minutes and seconds. Then mechanical clocks come in around the 14th century, which is when we started measuring time independently of the sun. That was a huge shift. Time stopped being just something that happened out there and became something we could keep in our pockets. But even now, time is something we measure, not something we touch. You can't scoop up a handful of time. You can't point to it. And if you didn't remember the past or anticipate the future, would it even exist to you? Let's try an experiment. Take a moment right now to notice your experience. What do you feel? If you're like most people, you feel like you're in the now, the present moment. But here's the catch. The brain is always a little bit behind. Everything you see, hear, and feel is delayed by a few dozen milliseconds because your brain is processing it. Technically, you're always living in the past, just a tiny sliver behind. So what's the present? A useful illusion. This is where it gets slippery because we experience time. But does that mean it's real? Next up, what Einstein broke and why he couldn't fix it. Okay, so let's mess with your head a little more. If you grew up thinking of time as a universal ticking clock, the same for everyone, everywhere, then Albert Einstein officially ruined that idea in 1905. And he did it with just 2 words. Special relativity. Einstein's theory didn't just redefine physics, it redefined reality. Before him, Isaac Newton imagined space and time as a kind of invisible stage where the universe played out. Things moved around, but the stage itself, solid, permanent, objective. Einstein looked at the same stage and said, actually, it's more like a trampoline. and that changed everything. Time is not absolute. Here's the simple version of what Einstein figured out. Time is relative. That means time moves differently depending on how fast you're going and how close you are to a massive object. It sounds wild, but it's real, and it's been tested over and over. We've put atomic clocks on planes, flown them around the Earth, and when they land, they're off compared to clocks on the ground. Not broken, just less time has passed for them. In other words, time moves slower for people in motion. It's called time dilation, and it's not just a theory. Astronauts on the International Space Station experience time slightly slower than we do on Earth. It's not enough to notice day to day, but it adds up, and it gets even weirder near massive things like black holes. According to general relativity, Einstein's follow-up act in 1915, gravity actually bends space and time. That's what gravity is. In this model, not a force, but a warping of space etime. Imagine putting a bowling ball on a trampoline. The surface bends. Now roll a marble. Nearby, it spirals toward the dent. That's how planets orbit stars and time. Time slows down the deeper you fall into that dent. Near the event horizon of a black hole, the edge beyond which nothing escapes, time stretches to infinity. To someone falling in, time might seem normal, but to someone watching from a distance, they'd appear to slow down forever. Frozen dot, let that sink in. In Einstein's universe, there's no single now. To people moving at different speeds or in different places, literally experience different realities of time. The future for one could be the past for another. That's not science fiction. That's GPS satellites, which have to account for relativity to give you directions accurately. So what does that mean? It means time isn't some universal ticker in the sky. It's part of a flexible 4D fabric, space-time. And how you move through that fabric affects your experience of time. But here's where it gets even stranger. Einstein's equations work perfectly. Even if you reverse time, the math doesn't care if you run the clock forward or backward. So why don't we see broken eggs reassembling themselves? Why does time only seem to move forward? To answer that, we need to talk about a different idea. A force that doesn't get enough love, entropy. So if Einstein says time doesn't have to move forward, if the laws of physics are totally cool with playing reality in reverse, then why does time feel like it only moves one way? Why can you remember the past, but not the future? Why do ice cubes melt, but never unmelt? Why do people age, but never de-age? The answer, at least the leading one, is something called entropy. And if you've never heard of it, buckle up, because this one's sneaky. It's one of the most important concepts in physics, and yet it hides in plain sight. Entropy 101. Entropy comes from the second law of thermodynamics. It's the idea that, in any closed system, disorder tends to increase over time. To put it in normal language, things fall apart, systems get messy, heat spreads out, energy dissipates. There's a natural tendency for order to become disorder. Think about a freshly cleaned bedroom. Over time, without even trying, it gets messy, but it never gets clean by itself. That's entropy. Or Imagine smashing a wine glass on the floor. You get 1,000,000 tiny shards, but no matter how long you wait, they'll never reassemble into a perfect glass. That's not because it's physically impossible, it's because it's unbelievably unlikely. There are trillions more ways for the shards to be disordered than ordered. And the universe, being indifferent, doesn't care about your glass. It just follows probabilities, entropy, and the arrow of times. So here's the thing. Entropy gives time a direction. It's like a one-way street. It's the reason we say there's a past and a future. Everything else in physics, motion, gravity, even quantum mechanics, works just fine in reverse. But entropy doesn't. Entropy always increases, and that defines the arrow of time. Now, this raises a bizarre question. If entropy increases over time, doesn't that mean time exists? You'd think so. But some physicists argue the opposite. They suggest that entropy isn't the result of time. Time is the result of entropy in other words, we feel the passage of time because the universe is moving from low entropy order to high entropy disorder. But that doesn't mean time is real. It just means change is happening. Think of it like watching a video of an explosion. You can tell which way is forward because the debris flies outward, not inward. But the video could be just a collection of frames. There's no need for real time, just a change in the state of the system. So what if the universe is just a series of states, and time is just the illusion that connects them? What about the beginning? This brings us to a cosmic level mystery. If entropy increases over time, then the universe must have started in a very low entropy state. That's what the Big Bang was. Not just an explosion of matter and energy, but an explosion of order. But why? Why would the universe begin in an incredibly unlikely state of perfect order? Nobody really knows, and that makes some physicists suspicious. Because if time only moves forward because entropy increases, and entropy only increases because the universe started in low entropy, then maybe time isn't a fundamental property at all. Maybe it's just a story we tell ourselves to make sense of why hot coffee gets cold, not the other way around. Maybe time is just how our brains track change in an otherwise static universe. But if that's the case, then what is the universe really doing? Let's dig deeper next. A universe without time, the block universe model. Imagine pausing your favorite movie, let's say Interstellar, right in the middle of a scene. That frozen frame captures a single moment, a slice of the story. But all the other moments, they're still there. The beginning, the end, the plot twists. They all exist, just not in the frame you're currently looking at now. Imagine every moment of your life, every heartbeat, every blink, every decision is like a frame in that movie, and all those frames exist simultaneously. That, in a nutshell, is the block universe. Time as a dimension, not a flow-the-block universe. Idea comes straight from Einstein's theory of relativity. Once you accept that time and space are part of the same four-dimensional thing, space-time, something really weird happens. Time stops being a flowing river and becomes more like a frozen landscape. You don't move through time, you're spread across it. The past, present, and future are all equally real. They all exist. You just experience them one at a time, like a needle on a record player. But the record, it's already written. This view is sometimes called a truth, and it has huge implications. It means your birth and your death and everything in between already exist on the space-time map. You're not traveling through time, you are time, or at least a chunk of it. And if you're thinking, that sounds totally unprovable, you're right, but it might still be true. The physics behind the Friesen special relativity. There's no universal now. People moving at different speeds disagree on what counts as the present. That's not philosophy, it's math. If there's no objective now, then there's no objective past or future either. Every moment is relative, so physicists, like Hermann Minkowski, who worked with Einstein, started seeing time as just another coordinate. If you have height, width, depth, you also have duration. And just like all points in space exist whether you're standing on them or not, all points in time exist whether you're experiencing them or not. Here's how physicist Brian Greene puts it. Just as we envision all of space as really being out there, as really existing, we should also envision all of time as really being out there, as really existing too. Kind of spooky, right? But this idea solves a lot of problems. It explains why the laws of physics are time symmetric, why equations don't care which way the clock ticks, and why, at the fundamental level, the universe doesn't need a present moment to function. It's just the whole thing already there. What happens to free will? Now let's get uncomfortable. If the future is already real, does that mean everything is predetermined? Do we actually choose anything? Or are we just playing out a script, one moment at a time? Some physicists dodge that question, saying the block universe doesn't prove determinism. It just describes structure, not cause. Others go full fatalist and say, yep, it's all already happened. You just haven't experienced all of it. Yet, philosophically, this connects to the debate between free will and determinism, and it's a minefield. Neuroscience shows that your brain makes decisions milliseconds before you're aware of them. That's real. But whether that supports determinism or not depends on who you ask. So, are we time-traveling meat machines locked into a 4D frozen sculpture of ourselves? Possibly, but what if the block universe is just too cold, too clean, too perfect? What if the universe isn't a statue, but a computation? Next, the simulation hypothesis and time as code. Let's shift gears from physics to something more speculative. Picture this: you're playing a video game, a richly detailed world, maybe something like Red Dead Redemption or Cyberpunk 2077. The characters move, seasons change, day turns to night. Time exists in that world, or at least it looks like it does. But behind the scenes, there's no ticking clock, just lines of code, updates, rendered frames. Now, imagine the entire universe is like that game, not running on a console, but on some hyper-advanced computer system, not built out of atoms, but of information, rules, logic, code. This is the simulation hypothesis. And if it's true, time might not be real at all. We live in a program, maybe the simulation. hypothesis isn't just a stoner thought experiment anymore. It's been seriously proposed by thinkers like Nick Bostrom, a philosopher at Oxford, who argues that if future civilizations can create high-fidelity simulations of conscious beings, and if they make lots of them, then statistically, we're more likely to be inside a simulation than the one civilization creating them. Wild, right? Elon Musk has even said, there's a 1 in billions chance we're in base reality. Let's be clear, there's zero experimental proof of this, but the idea is intellectually contagious. And here's where time comes in. In a simulation, time is just a variable, a clock cycle, a counter. Time doesn't flow, it updates. Frames render one at a time. Maybe at 60 frames per second, maybe at 10 updates per second, the plonk. Time, if you want to get quantum nerdy about it. So if we're living in a simulation, time isn't a universal property. It's part of the software. It might be paused, sped up, rewound, or branched, depending on what the programmers want. And this raises a terrifyingly cool possibility. If time is code, could it be edited? Could someone or something manipulate it? Time glitches, Darcia vu, and other bugs. Let's not go full Matrix here, but think about weird experiences, Darcia vu. The sensation that time is moving faster or slower, or even those lost time stories people tell. Could those be glitches in the system? Probably not. There are far more grounded explanations in neuroscience. Your brain is constantly rewriting your sense of time on the fly. It's like a DJ live mixing your memories. That alone could explain 99.9% of the weird stuff. But if time were a simulation parameter, it would explain a lot. Why quantum particles don't decide their state until measured like lazy code, waiting to be executed. Why time and space seem to be quantized, chopped into minimum measurable units like pixels. Why the universe has a maximum speed limit, light speed, like a built-in frame rate cap. Even physicist John Archibald Wheeler, mentor to Richard Feynman, once said, "Everything is information." It from bit, meaning the universe might not be made of stuff, but of data. In that case, time is a function. It has no reality outside the rules that created it. So, if time is an illusion, or at least a construct, what does that make? Are you a simulated mind riding a timeline that only exists in memory? Or is there another way to look at it? Maybe time isn't a flowing river. Maybe it's a loop. And that brings us to time travel next. What happens when you bend time into a circle? Alright, we've talked about time being flexible, maybe even fake, possibly just code. So now, let's do what science fiction does best. Break time completely. Let's talk time travel. The idea of jumping through time, forwards or backwards, has fascinated us for centuries. From H.G. Wells to Doctor Who to Interstellar, it's a staple of imagination. But how much of it is just fantasy? And how much has actual physics behind it? The answer is both simpler and weirder than you think. Because as far as the math goes, time travel isn't impossible. In fact, we've already done it. The easy kind. Forward time travel. Let's start with the part that's actually real. Time travel into the future happens all the time. It's baked into Einstein's relativity. Remember how time slows down when you move fast or hang out near something massive. That's not just theory, we've tested it. Astronauts on the International Space Station age slightly less than people on Earth. And if you could travel near the speed of light, say on a spaceship doing 99.999% of light speed, you could fly around the galaxy for what feels like a few years, and come back to find thousands of years passed on Earth. Wouldn't it be cool if that's straight up physics? So, forward time travel, totally possible, already done. But the juicy stuff is going backward, and that's where things get messy. The hard kind. Backward time travel, going back in time, introduces paradoxes. You've probably heard of the grandfather paradox. If you went back in time and accidentally stopped your grandfather from meeting your grandmother, do you cease to exist? Or the bootstrap paradox. What if you go back in time and give Einstein his own theory of relativity, meaning he never had to come up with it? So where did the idea actually come from? These kinds of paradoxes make physicists very uncomfortable, but interestingly, the equations of general relativity don't forbid them. In fact, they allow for something called closed time-like curves, paths through space-time that loop back on themselves. Mathematically, if you could find or build a structure that bends space-time in just the right way, you could travel along that loop and end up in your own past. One famous example is a wormhole, a hypothetical shortcut through space-time. If you could move one end of a wormhole very fast, slowing time on that end, and then bring it back, the two ends could be out of sync. Walk through the right way, and you've gone backward in time. So, why aren't time tourists visiting us from the future? Physicist Stephen Hawking once threw a time traveler party, but sent the invitations after it was over. No one showed up. His conclusion: time travel to the past probably isn't possible, or else the timeline is very good at protecting itself. So, timelines. Some theories suggest that paradoxes fix themselves. This is called the Navikov self-consistency principle, the idea that if you try to change the past, your actions will just end up being part of the story all along. You can go back, but you can't change anything in a way that creates a contradiction. Kind of like the timeline is immune to you. But here's the bigger question. If time can be bent, looped, or reversed, if past, present, and future can all exist simultaneously, then maybe time isn't a straight line at all. Maybe it's a weird, tangled web of causal connections. Maybe your future actions cause your past, or your memories are written retroactively by your future self. This takes us deep into the philosophical swamp of free will, determinism, and causality. But before we get lost there, let's ask something even more mind-bending. What if time is emergent, not a fundamental feature of the universe, but something that arises from something deeper, something even weirder than time itself? Next up, what if time emerges from quantum entanglement? Time may feel like the most basic thing there is, like it's stitched into the universe at the deepest level. But what if it isn't? What if time is not fundamental? This is one of the most intriguing ideas in modern theoretical physics. Time might be an emergent property, not something the universe was born with, but something that appears when other things, like matter, energy, and quantum information, interact. And at the heart of this idea is one of the weirdest, most misunderstood phenomena in science. Quantum entanglement. Quantum entanglement. Spooky action at a distance. Let's recap quickly. Quantum entanglement happens when two or more particles become linked in such a way that their states are correlated, no matter how far apart they are. You measure one, and boom, you know something about the other instantly. Einstein hated this. He called it spooky action at a distance. And for decades, physicists argued over whether it was real. It's real. We've tested entanglement thousands of times. It's not magic. It doesn't send information faster than light. But it does suggest something fundamental, that particles aren't really individual, independent things. They're part of larger, interconnected systems, and those systems don't seem to care about space or time. That's where things get interesting. Time from entanglement. A growing number of physicists, including heavy hitters like Sean Carroll, Carlo Rovelli, and teams at places like Perimeter Institute, have been exploring the idea that time itself might emerge from patterns of quantum entanglement. One version of this idea comes from the Page and Wouter's mechanism, proposed in the 1980s. It goes like this. Imagine the whole universe as one gigantic quantum system, an entangled blob. If you look at the universe as a whole, it doesn't evolve. It just exists. But if you're inside the universe, and you're just looking at a part of the system, you see change. That change, the difference between one entangled state and another, is what we perceive as time. In other words, time is relative to your perspective, not just in Einstein's sense, not just your speed or location, but in terms of what part of the system you're entangled with. If this sounds like science fiction, just know that experiments have actually tested simplified versions of this idea with photons, and they worked in these tests. When you treat a quantum system globally, nothing evolves. But when you look at a part of it, time seems to appear. Not as something fundamental, but as a kind of internal bookkeeping system for relationships between entangled components. Think of it like this. Imagine the universe as a giant orchestra frozen in a single chord. From the outside, nothing's moving. But from the inside, from the perspective of a single instrument, you hear harmonies, dissonance, changes. You experience music. That music is time-loop, quantum gravity, and timeless physics. Carlo Rovelli, one of the leading figures in loop quantum gravity, takes this even further. He argues that time doesn't exist in the most fundamental equations describing the universe. In fact, many attempts to merge quantum mechanics with general relativity end up erasing time entirely. It just drops out of the math. Rovelli suggests that what we think of as time is just a useful approximation, something that emerges when certain conditions are met, like temperature emerges from the motion of molecules. But it's not real in the way we think. If that's true, then asking what happened before the Big Bang might be like asking what's north of the North Pole. There might not be a before, just a condition of the universe where time hadn't emerged yet. So where does that leave us? If time is just a side effect of entangled particles, or an illusion created by limited perspective, then what's really real? Maybe nothing happens in the universe. Maybe everything just is. Next up, what if consciousness creates time? Let's take a moment and ask something radically personal. What if time doesn't exist? Unless you do. Let's be real. Most of what we've talked about so far has been from the outside in. Physics, equations, models of the universe. But here's something often overlooked. Your experience of time, the way you feel the seconds slipping by, the memories, the anticipation of the future, that's all happening inside your brain. And some scientists and philosophers believe that this internal experience of time might not reflect anything fundamental about reality. It might just be a trick of consciousness. The brain's time machine. Your brain is not a stopwatch. It doesn't perceive time directly. It constructs a model of the world, including time based on sensory input, memory, and internal feedback loops. There's no dedicated time center in the brain. Instead, multiple systems work together to generate your sense of past, present, and future. The cerebellum handles short intervals like milliseconds. The hippocampus is key for forming and recalling memories. The prefrontal cortex helps project possible futures. The insular and basal ganglia track time intervals. You don't just experience time, your brain actively builds a timeline out of neural noise, and it edits constantly. Experiments show that people perceive simultaneous events as happening at different times based on expectations. The brain also delays signals slightly so it can sync up audio and visual inputs, and it fills in missing information. Bottom line, your experience of time is stitched together after the fact, like a movie edited in real time. The now doesn't exist. Here's a disturbing idea. The present moment you feel so deeply attached to, it might not exist. According to philosopher Daniel Dennett and neuroscientist David Eagleman, what you perceive as now is actually a narrative your brain constructs by stitching together information from the last few hundred milliseconds. That stitching process creates the illusion of continuity. In fact, there's no fixed moment where all your senses synchronize. Your visual system reacts faster than your auditory one. Touch, pain, and motion all have different processing speeds, and your brain just smooths it all over. It's not a live broadcast. It's more like a slightly delayed highlight reel. So when you say I'm living in the present, what you really mean is I'm experiencing a brain-generated reconstruction of events that already happened. Weird, huh? Memory creates time. Now flip that forward and backward. Why do we feel the past exists, but not the future? Because we remember the past. Your memories anchor you to a timeline. They create a sense of continuity of self that gives the illusion of time's direction. In physics, there's no preferred direction, but in your brain, there's a very clear arrow. Some researchers think this is why time feels real. It gives your consciousness a framework. Before, during, and after. Without it, you couldn't form identity, make decisions, or function socially. Consciousness might be fundamentally tied to the illusion of moving through time. And the philosopher Julian Barbour goes even further. He argues in his book The End of Time that the universe is made up of now's individual static snapshots. Time doesn't flow. You just happen to be experiencing one of those snapshots, and your brain contains records, memories of others. That's What creates the illusion of time? It's not the universe that changes, you do. Is time a feature or a bug? So let's zoom way out. What if time isn't something the universe needs, but something we need? A mental construct that helps us process causality, motion, change. A scaffolding for decision-making and learning. A tool, not a truth, that doesn't mean it's fake or useless. Illusions can be real to us, just like color is a construct of the brain interpreting light. But it means the flow of time might be nothing more than a side effect of biology your dog doesn't think about. Next Thursday, an aunt doesn't stress about aging, and a rock. A rock doesn't care what time it is. So what does that mean for how we understand the universe? Maybe we've been looking at time all wrong, from the inside out, instead of the outside in. Next, let's take a detour into black holes and see what time does when it's pushed to its absolute limits. If you want to see time completely lose its mind, there's one place in the universe that pushes it to the breaking point. Black holes, these cosmic monsters, aren't just the densest things we know of. They're where our understanding of time goes to die. Literally, because if you fall into a black hole, time itself changes. Not just how fast it ticks, but what it even means. Let's break it down. Gravity versus time. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape. They're created when massive stars collapse in on themselves, crushing all their mass into an infinitely dense point called a singularity. Surrounding that singularity is the event horizon, the point of no return. Here's where things get weird. Einstein's general relativity tells us that gravity isn't just a force, it's the curvature of space-time. And the stronger the gravity, the more space-time bends, so near a black hole, space-time bends a lot. Time slows down the closer you get to the event horizon. To someone watching from a safe distance, you'd appear to move slower and slower as you fall toward the black hole until you freeze at the edge, forever. From your own perspective, though, time seems to pass normally. You fall straight through the event horizon, blissfully unaware, at least until the tidal forces rip you apart like spaghetti. More on that later. This is real. We've confirmed gravitational time dilation by observing clocks on Earth at different altitudes. Black holes just crank that to 11. In fact, near the event horizon, the difference in experienced time becomes infinite. Time travel via black holes. Let's say your twin stays far from a black hole while you orbit close to the event horizon for a few hours. When you return, thousands or even millions of years could have passed for your twin. So, in a sense, you've time traveled into the future. This is actually used in Interstellar, where the crew visits a planet orbiting a supermassive black hole. A few hours for them equals decades back on Earth. And while that part of the movie took artistic liberties, the core idea is rooted in real physics. It's called gravitational time dilation, and it's not a trick. It's baked into space-time itself. So, could black holes be used to travel backward in time? Probably not. While some speculative models suggest that rotating black holes, called Kerr black holes, might have wormhole-like tunnels inside them, most physicists think you'd never survive the trip. The math gets unstable. And even if time loops were theoretically possible, you'd run into paradoxes or need exotic matter that we don't know how to make. What happens inside? Now let's talk about the singularity, the place at the center of the black hole where everything breaks down. According to general relativity, the singularity is a point of infinite density and zero volume. That's already pretty wild. But it also flips our understanding of time at the singularity. Space-time becomes so curved, so distorted, that the usual rules stop applying. Some physicists believe that time ceases to exist at this point. It has no direction, no duration, no meaning. Roger Penrose, a longtime collaborator of Stephen Hawking, described it like this: the singularity isn't a place in time, it's a place where time ends. Which raises a huge question. If time stops inside a black hole, what happens to information? This leads us to one of the biggest puzzles in physics, the black hole information paradox. Quantum mechanics says information can't be destroyed, but black holes seem to do just that. So which theory is wrong, quantum mechanics or general relativity? Hawking spent decades wrestling with this. His final answer: information does escape, encoded in subtle changes to the black hole's radiation. But we don't fully understand how. Here's the punchline: black holes don't just mess with time. They challenge our most basic ideas about reality. And if time can end or be paused or stretched infinitely, then what is it? Is time a real thing that breaks under extreme conditions? Or is it a convenience that stops being useful when nature gets too intense? Next, let's flip the scale. What does time mean at the quantum level? We've been to the edge of the cosmos. Now let's zoom all the way in, past atoms, past protons, into the bizarre and often baffling world of quantum mechanics. Here, time plays a very different and arguably less important role, because at the quantum level, time might not be real at all, or at least not the way we think it is. Time in classical versus quantum physics. In classical physics, Newtonian mechanics, time is absolute. It's the invisible grid on which events unfold. That's how most people intuitively understand it. You drop a ball and it falls through time. But in quantum mechanics, things are fuzzier. Time is treated more like a background parameter, something that's just there, ticking along in the equations, but not something we measure directly. What's even stranger is that almost all the fundamental quantum equations, like the famous Schrödinger equation, are time-symmetric, meaning if you reverse the direction of time in the math, the equations still work. This is weird because our everyday experience of quantum stuff, particles decaying, wave functions collapsing, seems very much time-directed. So what's going on? Let's start with the basics. The Schrödinger equation doesn't care about time. The Schrödinger equation describes how a quantum system evolves over time. But the way it treats time is odd. Time is not an operator like position or momentum. It's just a parameter, a number you plug into the equation. So in quantum mechanics, we don't really observe time. We just assume it's there in the background, moving things along. Time tells the wave function how to evolve, but it's not something you can measure the same way you can measure, say, the spin of an electron. This has led many physicists to argue that time might not be a fundamental part of quantum mechanics at all. Instead, it could be something that emerges when quantum systems interact, especially when they decohere into classical systems we can actually observe. Quantum collapse. The time problem, one of the central mysteries of quantum mechanics, is the measurement problem. Here's the issue. Until a quantum particle is observed, it doesn't have a definite state. It exists in a superposition, like Schrödinger's famous cat, both alive and dead. But the moment you observe it, the wave function collapses, and the particle snaps into a definite state. Here's the weird part. That collapse is not time reversible. You can't go backward from a collapsed state to the original superposition. So while the rest of quantum mechanics is time symmetric, measurement ISN, single quotes, this has fueled debates for decades. Does the act of observation create time's direction? Is consciousness involved? Or is measurement just another type of entanglement with the environment? Some physicists, like Wojciech Zurek, argue that dicoherence, the loss of quantum superposition due to interaction with the environment, is what gives rise to the appearance of a classical world and possibly time itself. In this view, time is what happens when quantum systems lose their quantumness. The timeless quantum universe now. Let's go deeper. In attempts to unify quantum mechanics with general relativity to make a quantum theory of gravity, something weird keeps happening. Time disappears from the equations, literally in the Willard-DeWitt equation, a key proposal in quantum gravity. There's no time variable, none. This has led people like Julian Barbour, yes, him again, to propose that the universe is fundamentally timeless, a static collection of quantum states, with time as an emergent illusion based on the sequence of configurations we experience. He calls this idea Platonia, a mathematical space containing every possible moment. You're not moving through time, you're just experiencing a particular now, and your brain gives it context by remembering previous ones. Kind of like a flip. The images don't move, you move through them. If quantum reality is fundamentally timeless, then maybe the flow of time is just how conscious observers interpret transitions between different entangled states, which raises the same mind-bending question from earlier. If no one were observing the universe, would time exist at all? Weirdly enough, some interpretations of quantum mechanics say no. That brings us to something even stranger. The many worlds interpretation, where time doesn't move forward, it just branches. Next, what if every moment splits the universe into new timelines? Let's say you're sitting at a coffee shop. You reach for a muffin, blueberry or banana. You pick blueberry. The banana muffin stays in the display case. No big deal, but what if somewhere in some parallel version of reality, you picked the banana? Not just could have picked it. Did. Welcome to the many worlds interpretation of quantum mechanics, one of the most famous and famously strange takes on how the universe works. And it has huge implications for time. Because in this view, time isn't a river, it's a branching tree, and every quantum event is a split. What is the many worlds interpretation? In the 1950s, physicist Hugh Everett III proposed a radical solution to the weirdness of quantum mechanics, especially the idea that a system is in a superposition until observed, his idea. The wave function never collapses. Instead, every possible outcome actually happens. They all play out, just in separate, non-communicating branches of the universe. You pick blueberry, that happens. You pick banana, also happens in a different world. According to this view, the universe is constantly splitting, not at the level of sci-fi alternate histories, but every time a quantum event could go multiple ways. Particles, atoms, electrons, and by extension, you. This doesn't mean there are infinite copies of you running around. It means you are part of a constantly branching quantum system, and the version you experience is just one branch of many. So what does this mean for time? Time doesn't flow. It branches in many worlds. The idea of a single, linear timeline is gone. Instead, every moment is a node, and each quantum interaction branches the timeline. Think of it like a fractal tree growing infinitely in every direction. So, when you look at a clock and see it tick from 3 o'clock to 3:01, you're not witnessing a universal next moment. You're sliding along one of many possible branches that emerged from the quantum soup a nanosecond ago, and that makes the future fundamentally unknowable, not just because you haven't seen it yet, but because there is no single future. There are countless. This also messes with causality in strange ways, because in many worlds, every choice you make or don't make splits reality. It's not that time passes and then you choose. It's that choosing is how time branches. Time isn't a sequence, it's a structure, and your path through it is just one of infinite trajectories. Can you visit other branches? Here's the obvious sci-fi question. If all these alternate timelines exist, can we jump between them? So far, there's no evidence for that. The different branches are thought to be non-interacting. Once they split, they don't overlap. Think of it like radio stations. They're all around you, but you can only tune in to one at a time. That said, there are some fringe proposals in quantum computing and decoherence theory that suggest interference between branches might be detectable under very specific circumstances. But this is bleeding-edge stuff. Nothing conclusive yet. Still, the many worlds model is taken seriously by a lot of physicists because it has one big advantage. It's clean. No wave function collapse, no special observer, no weird exceptions, just the math applied literally. But it raises a massive question. If every version of every outcome exists, then what is now? Why are you experiencing this moment in this branch? Could time and your identity just be the feeling of riding one quantum branch while an infinite forest of others blooms around you? And if that's true, who's the real you? We'll get weird with that idea next. Up next, what if time and self are illusions created by a simulation of memory and causality? Let's take a moment and ask, if you woke up tomorrow with no memory, no sense of what came before, no idea who you are, where you are, or what day it is, would time still feel real? You'd still see things change, hear sounds, move your body. But would you feel the passage of time? Would you know that one moment leads to the next? Probably not, because your sense of time is tied to your sense of self, and that opens a whole new door. What if you like time, is a simulation, built from memory, causality, and pattern recognition. The you illusion you probably think of yourself as a continuous thread, one person moving through time. But neuroscience tells us something different. You are a constantly updating mental model, a simulation your brain is running. The psychologist Thomas Metzinger calls this the phenomenal self-model, the idea that what you call I is not a thing, but a process, one that includes memories, emotions, goals, sensory input, and crucially, a timeline. In other words, you aren't a person who experiences time. You're an experience that creates the illusion of being a person. In time, it's kind of like how a character in a video game exists inside the game world. They don't know their code, but everything they feel, movement, action, even memory, is just the game's engine updating states. Your brain does the same thing. Causality, the backbone of the illusion. Here's a key idea. The human brain is obsessed with causality. We don't just observe change, we explain it. We assume a causes B because we saw A happen first. Our entire experience of time may just be the brain creating a causal narrative. But causality itself isn't always clear-cut at the quantum level. Experiments in quantum physics, like delayed choice quantum erasers, have shown that in some situations, future measurements can appear to affect past events. No, this doesn't mean time travel, but it suggests causality may not be fundamental. It may be emergent, just like time, just like self. In that case, your entire experience of I was here, then I did that, now I'm doing this, might be a narrative fiction built to make sense of a world where no such thread actually exists. This isn't just philosophical navel-gazing. In artificial intelligence research, one of the most powerful tools for learning is the predictive model agents that simulate what will happen next. Based on previous input, you do the same thing constantly. Your brain predicts the next note in a song, the next word in a sentence, the next movement in a dance, milliseconds before it happens. Some researchers, like Carl Friston, argue that consciousness itself might be a kind of prediction machine, and time is the coordinate system we invent to make those predictions work. Time is memory. Memory is time. Here's something trippy in certain forms of brain damage, like severe antegrade amnesia. Patients can't form new memories. They live in an eternal present. They don't perceive time moving forward because, to them, it doesn't single quotes. Meanwhile, people with déjà vu or certain types of epilepsy experience false memories, moments that feel like they've already happened. Their brain gets the timing of memory encoding wrong. In both cases, the feeling of time gets warped, and that tells us something huge. Time, as we experience it, is a product of memory. Without memory, there's no sense of past. Without imagination, there's no sense of future. Without change, there's no now. So what if time is just the side effect of a brain building an internal model of cause and effect? Not because the universe needs time to work, but because you do. Next up, if time isn't real, then what is real? Okay, so we've dismantled time from just about every angle: physics, neuroscience, consciousness, cosmology, even simulations. We've seen how it bends near black holes, breaks at the quantum level, disappears from equations, and might just be an illusion created by memory and change. But now we're left with a much bigger, messier question. If time isn't real, then what is real? What's actually there, beneath all the clocks, calendars, and conscious experience? Let's explore a few of the leading and competing ideas. 1. Reality as a state, not a process in most of our daily experience. Reality feels like a process. Things happen. One thing leads to another. Stories unfold. This is the intuitive, time-based view of the world. But in physics, especially in quantum gravity and some interpretations of cosmology, reality might not be a process at all. It might be a configuration, a state. Imagine the universe as a single, timeless, mathematical object, a giant, multi-dimensional structure that simply exists. In this view, time is just one way to slice it, like cutting a loaf of bread into moments. This is the essence of the block universe, which we talked about earlier, and also what Julian Barbour refers to with his Platonia concept, a landscape of all possible configurations of the universe, with no need for time to connect them. From this perspective, the universe doesn't evolve. It is, and your experience of change is just the sensation of moving through, or perceiving one configuration after another. 2. Reality is information. Increasingly popular idea in physics is that information is more fundamental than matter, energy, or even space-time. Theoretical physicist John Archibald Wheeler famously said, "It from bit," meaning everything that is comes from binary information. Yes, no, 1, 0th, quantum state, or not. This lines up with developments in quantum computing, black hole thermodynamics, and holographic theories, all of which suggest that the universe might be a kind of information processing system in this view. What's real isn't stuff, it's relations, bits, data, entanglements, the links between things and time. That's just how information gets updated. So, instead of a universal clock, we might have a vast web of informational states, some more stable than others, and the flow of time is just the progression from less probable to more probable configurations. It's not a timeline. It's a state machine. 3. Reality is experience, maybe. Now, here's a controversial idea, but one gaining traction in some corners of cognitive science and philosophy. Maybe what's real is not matter or time or even information. Maybe it's conscious experience. This is called panpsychism by some, neutral monism by others. But the core idea is this: what exists, fundamentally, is experience, subjectivity, awareness, and everything else, time, matter, causality, is built on top of that. In this view, the universe isn't a machine. It's not a simulation, or a block, or a code base. It's a mind-like structure, and your experience of time is one of its many perspectives. Physicist Carlo Rovelli, who helped develop loop quantum gravity, leans toward this. He's argued that maybe our search for an objective now is doomed because now is always from someone's point of view. If we give up the idea of a universal reality and instead focus on relational reality, things existing in relation to observers, then time doesn't disappear. It just decentralizes. It stops being the master key and becomes just one of many ways we relate to the universe. So what's left if time is an illusion? If matter is emergent? If space can be bent, erased, or simulated? Then we might be living in a universe where change, consciousness, and information are all just surface-level effects of something deeper, something timeless, structureless, and completely alien to human intuition. And that's not a failure of science. It's a frontier, because here's the truth. Every time humans have asked what reality really is, we've had to let go of something we thought was fundamental. Earth isn't the center of the universe. Matter isn't solid. Time might not be real, and whatever comes next, whatever deeper layer we discover, might require giving up even more. Next up, how would our lives change if we truly accepted that time isn't real? Let's say tomorrow, humanity wakes up to a scientific consensus. Time is not real. Not metaphorically, not poetically, but in a hard, physical, testable sense. The flow of time, the past-to-future structure we all rely on, is an illusion. A byproduct of entropy, perception, or information processing. It doesn't exist outside our models. What would that actually mean for our lives? Would anything change? Would everything change? Let's explore. Everyday life. Would it feel any different? First, the obvious. Your alarm clock will still go off. Your coffee will still cool down. You'll still be late to work. Because regardless of whether time is real or not, the experience of time is deeply functional. It's how our biology and technology are built. Your body has circadian rhythms. Your phone syncs with atomic clocks, and the economy runs on schedules. So even if time turns out to be a kind of illusion, it's an extremely useful one, like money. Money is just numbers in a database, but we treat it as real, and it has real effects. Time might be the same, but beneath the surface. There could be profound shifts in how we think about ourselves, our decisions, and the nature of existence itself. Free will, regret, and responsibility. If time isn't real in the way we think, if past, present, and future all exist in some block or computational structure, then our view of free will takes a hit. In a timeless universe, there's no future to choose. Every moment already is. Your decisions aren't being made in real time. They're just part of the structure, like stones in a riverbed. Does that mean you're not responsible for anything? Not necessarily. Just because a choice exists within a structure doesn't mean it's meaningless. Think of a book. Every page is already written, but the characters still make decisions, and those decisions matter within the story. If time is static, then maybe moral responsibility is about owning your part in the structure, not controlling the whole thing. But what about regret? If the past can't change and the future can't be altered, does that make regret pointless? Maybe, or maybe it just reframes it. Regret becomes not about changing what was, but understanding how each now fits into the whole, like seeing the full arc of a melody rather than wishing you played a different note. Mortality and meaning, here's where it gets heavy. Much of what gives life urgency is the sense that time is limited, that we're heading toward an ending, that there's a ticking clock. If time is an illusion, if all moments already exist, what does that mean for death? It could be terrifying or comforting. From a block universe view, your death already exists, but so does your birth, and every moment in between. They're all equally real and eternally part of the structure. You never stop existing. You just stop appearing in certain slices. In that case, your life isn't a candle burning out. It's a sculpture, complete, permanent, immortal. In a weirdly literal sense, that doesn't make grieving any easier. But it offers a strange kind of peace, and it reframes meaning. If time isn't real, meaning can't be about goals or futures. It has to be about this exact configuration, this conscious moment. It's not where am I going, it's what am I being right now. Relationships in a timeless world, think about love, friendship, connection. They all seem built on time. We've known each other for years. I'll love you forever. We've been through so much. But in a timeless view, relationships aren't processes. They're patterns. You and the people in your life form a specific arrangement in the space-time structure. That arrangement doesn't need time to be meaningful. It just is. Maybe your love exists not because of what you've been through, but because of how your minds resonate in this particular configuration of the universe. And maybe that's enough. Would society collapse? Probably not. People still need to eat, sleep, and get to work. Laws still apply. Deadlines still exist. Our collective systems are too entrenched in the illusion of time for them to dissolve overnight. But culture might shift. Art, spirituality, and philosophy would adapt first, embracing timelessness, exploring non-linear storytelling, reframing human experience. Imagine music composed not in sequences, but in state clusters. Films without chronological order. Meditation practices aimed at exiting the illusion of time. Over generations, we might move toward a more now-centric society, one less obsessed with planning futures and more attuned to presence, pattern, and participation. A world less about chasing clocks, more about inhabiting moments. So what would change everything and nothing? Time would still appear to pass, but our understanding of it would evolve. We'd shift from treating it as an external master to seeing it as an internal map, like realizing you're not walking on a road, you are the road, and just maybe that would make us better stewards of each moment we inhabit. Next up, let's ask the ultimate question: why do we experience time at all? Let's put everything on the table. We've explored time from every angle: physical, philosophical, neurological, even hypothetical. We've seen how it breaks under extreme gravity, evaporates in quantum mechanics, and maybe doesn't even show up in the deepest equations of the universe. So here's the final, profound question. If time isn't real, then why do we experience it so vividly? Why does time feel like it's flowing, ticking, pulling us forward, when physics says it might be static, non-existent, or even illusory? Let's break this down. The evolution of time perception. One way to approach the mystery is from biology. Why did evolution build a brain that experiences time? From a survival standpoint, time perception is a superpower. Imagine being a creature with no sense of before and after. You wouldn't remember where food is. You wouldn't anticipate threats. You'd be eaten or starve or fail to reproduce. Not ideal, so nature didn't need real time. It just needed useful time. Time then might be like a user interface, a simplified model of a far more complex reality. Evolution built this interface so we could interact with the world efficiently, not accurately. Cognitive scientist Donald Hoffman compares this to icons on your desktop. When you drag a folder into the trash, you're not interacting with tiny files inside a metal can. The interface hides the messy complexity underneath, just like time hides the underlying physics. So maybe time is just one piece of our mental operating system, the brain's. Pattern addiction. Another reason we experience time might be because the human brain is addicted to patterns. We're always looking for cause and effect, before and after. First this happened, then that. The mind is constantly organizing information along a temporal axis, whether it's music, language, motion, or memory. Even your sense of self is built on this. Who you are isn't just a bundle of traits, it's a story, and stories only. Work with time. This is why some altered states, like deep meditation, psychedelic experiences, or neurological disorders, mess with time perception. When the brain's ability to model cause and effect breaks down, time itself seems to fall apart. And for some, that's terrifying. For others, it's liberating. But it shows one thing clearly. Time is something your brain is actively doing. Time. As the price of awareness now, here's a deeper idea. Maybe time isn't just a tool. Maybe it's the cost of being conscious to be aware. You need contrast, change, difference. A static universe wouldn't be perceived, it would be ignored. So consciousness might require the ability to detect variation. And that means tracking something like time. In other words, to notice anything, there must be a before and an after. Time might be the scaffolding of awareness. It's the lens that lets us see a changing world, even if the change is an illusion, or the world itself is frozen. Think of it like a movie. The film reel is a strip of static frames. But when projected through a light at speed, you get motion, story, emotion. Your brain is the projector. Time is the speed. Awareness is the light dot. No time, no experience. The universe, as observer now, for the wildest idea of all. What if the universe experiences time through us? We tend to think of the cosmos as cold, indifferent, timeless. But maybe conscious beings are how the universe knows itself. Maybe time is what it feels like for the universe to become aware of its own configuration, one piece at a time. This idea shows up in certain interpretations of quantum mechanics, in Buddhist philosophy, in psychedelic science, and even in ideas like integrated information theory. The theory goes, consciousness is what happens when information integrates and reflects on itself. Time is the structure that enables that reflection. If so, then time isn't a thing out there. It's a relationship, a structure of comparison, a bridge between awareness and the world. In this view, time is less like a river and more like a mirror. one that reflects the infinite possibilities of the universe back at itself. And that's why you experience it, not because the universe has time, but because you do so. Where does this leave us? Is time real? Is it an illusion, a simulation, a side effect, a story? Maybe all of the above. What matters is that by asking the question, by pulling at the threads of what seems obvious, we start to see reality differently, not as something fixed, but as something stranger, deeper, and maybe more beautiful than we imagined. So here's your final question. If time isn't real, what are you going to do with this moment anyway?